This is Klaus, and this is Peng. So we want to give an introduction about our work to optimize the training performance for a large language model in Kubernetes. We did lots of work for this in the last year, so we want to give an introduction about this part. About ourselves, who we are here. This is Klaus from NVIDIA. I'm the co-founder of Volcano. Currently, I joined NVIDIA for about 3 years, focus on the network part, for this one. Yeah.
I'm Peng. I'm from a technical startup. We're still in stealth mode, so that's why I'm not showing my company name on there.
Okay, great. Yeah. So we are talking about performance enhancement, but before that, I want to some kind of discussion about when we're talking about. I think in this KubeConf we have lots of discussion about batch system, right? So at least in my point that batch system is trying to help us to manage the workload, right? Including the workload life cycle, threading, and several things. The other important thing related to this topic is that our major task is to match the design performance of hardware, right? For the hardware, we including the computing resource, right? GPU, DPU, we including several things. And the other thing is the networking part. I think this is today's topic, so what we have done about this part. For networking resource, we have InfiniBand, we have Rocky, and bound-wise, healthy, and also the latency is also important for large language modeling. And the third one, I think, is also storage things, right? We have cache, we have local disk, and we also have, distributed storage future for some processed data, also several important things, right? This is a common things of batch system. Every batch system should handle related stuff for this plan. The next thing is that based on the batch system define what we want to build for batch system, we have a Volcano here, right? For Volcano, this is the, banner or the description of Volcano parts of Volcano project. So Volcano is a CNCF incubating project, and it is the first batch scheduling system in CNCF. It's a start from cool batch since 2017. This is a long time ago. We built a lot of features. And based on the batch system, what we want to build, now the first one is a computing resource. We build a lot of features to enhance GPU and CPU resource usage. Now the first one, we list a lot of features here, such as the dominated resource fair share and some common fair share for lots of things. We have job level, we have queue level, and also namespace level. Fair sharing to balance the workload between the different things. And today's topic is about networking resource, right? Before this topic, we build the task topology we are scheduling. This is major for the task topology, such as the PS worker mode in test and flow part. We have performance, and when you check the history of Volcano, you can get the performance report about this part. And today's topic is the networking topology we are scheduling. So we did some enhancements for in Volcano, and we also have some pipeline for that. I will give a quick introduction, and Peng will give a demo for what we have done in last year. And the third one is, I think, is in pipeline in our pipeline. That's right. For example, we have data-aware scheduling. For example, we have all information about the scheduling, so we will try to do something like data preloading to save the effort or save the improve the performance of the whole workload, right? The next one is the Volcano. Why Volcano is we introduce a lot of feature. We introduce a lot of feature every year, every month. So why we can do that? In Volcano, we have two-level kind of plug-in machinery. Now the first one is we have the in the middle line, right? This one is action. So if you want to build some action personally, right, such as in queue, such as the preemption, descheduler, you can do the action yourself, right? This is also the plugin point. For example, for the common part, for the other scheduler, you can just use a predefined entry point. This is not, you cannot modify this one. If you want to change the upstream, this will take a lot of time for yourself. But in Volcano, you can do the modify the allocation steps yourself, right? The third one, the last one is the plugin. This is a common part. We build lots of plugin here. For example, we keep the backward compatibility in the upstream, and we import all the things from the Kubernetes default scheduler, and we also build our own differentiation scheduling part, such as listed in the previous slides, for example, DRF and preemption, several things. In the cache side, we did several enhancements to cache the data from the API server. Because in scheduler, we have lots of data change, status change about the job, about the pod. So we try to avoid, try to minimize the API interaction with the API server. Because during our performance test, we found that some bottleneck is from API server. Lots of scheduler send lots of requests to API server part. And on the right side, we have a kind of code, right? This is the example. So the green box is that after you finish the interface, right? You just need to import this API, import this package into the main workload, and then you can enable your customized plugin yourself. So you can build your scheduler yourself. This is a simple, no change to the upstream. Everything is open. So this is why we followed everything from the Volcano to do that, right? Yeah, this is the Volcano part, right? We have the basic framework. We have cache. We have built several things. Now, when we talk with Peng about this case about large LLM training, so we found something that some challenges that now the first one is GPU scheduling part, right? We need for the large language modeling, training we need lots of GPU, and this feature already support. And the second one is we also need to networking enhancement. The second one is boundwise, low latency, and related networking things. For example, in the future, we also want to introduce a healthy part. When we found this thing and back to Volcano, we found that we already list the feature here. We found that the computing resources are already there. GAN scheduling and several existing features already supported. The next one is we try to, what we can do is try to support networking part. Green highlight in right, so we are going to have a networking part. Okay, for the networking aware scheduling, so currently we have, in a data center, we have several networking part, right? In a rank, we usually use the NVLink to do the interaction. And when we cross the rank, we usually have several layers of switch. And then we usually use infinite band or Rocky to share the data, across the rank. So we are going to have several things for this one. But in the upstream, and most of the case is that we define everything as a kind of the static, right? With just use the label or just put a configuration file that right. This is the simple one, right? In Volcano, we try to define a CRD, right? To define all the things. On the left side, we can see that on the left side is I think the network scheduling is the idea is the straightforward, at least for the static part, for the topological part, because we want try to minimize the paths of data transaction between the different nodes. This is the simple one. We try to avoid the data data paths. Try to avoid we didn't went through the switch if this is not necessary or not required. So we define the interface. On the left side, we define the CRD. We call it a hypernode, right? In hypernode, we have we had a tier For example, tier 1, tier 2, this is a different layer of switch. And we also have a different different selector. We have exact match to select a single node for this one. And for job, it is simple, right? In Volcano job, we can use this topology to make it, soft match or required match for those things, right? I think currently we define the CRD. We support the basic interface for the topological aware scheduling. So we also try to, unify the API of NVLink, IB, and Rocky because we want to manage all the interface for all the networking for this part. For example, partition, fabric, several things. And then we try to do the auto discovery about the service, right? We in NVIDIA we just released some feature DPF recently. It's including the network accelerator and also the snap. It is the storage things. And we also do the discovery. This is in the pipeline we are going to show. And on the bottom, we always show the CRD enhancement. I think in the future, we are going to do everything about for example, the healthy. We are going to show something that the network is ready or not, or when it's ready, how many times it's a kind of failed. So if this are lots of condition is not ready, that means this node is not stable. So we also consider all those things from our side. Yeah, I think this is a major feature from the Volcano part. I think this is a simple introduction. Also, Peng will give a demo for this part.
Thank you, Klaus, for introducing me. Good afternoon, everyone. I know you have a long day here, and this is not dinner time. And I promise I will not take too long, and this section will end before your Uber Eats arrive. Okay. All right. So yeah, here we're a cloud builder that we build GPU cloud, and then we want to have network topology aware in our scheduler, and that's why we have been watching the evolution of the network topology awareness in scheduler. We see that at the early stage in 2019, there is already standard topology labels introduced into Kubernetes, including the region and zone, and then you can also customize your own labels as well. And then in 2020, there's something called pod topology spread feature. That's what we released. And then recently, I think in January of this year, Volcano topology aware scheduling now is a feature that's in preview. And then we cannot wait. We just jump on it and try it out. So that's why we're here. Let's see. Does it work? Why do we choose Volcano scheduler? First of all, because our GPU cloud is built for AI training, so GAN scheduling is a must-have feature. And at like 2 years ago, there's not much scheduler who supports this feature. So that's a key feature that we want. That's why we choose Volcano. And then, of course, because that's GPU cloud, so we have to support GPU, CPU, and memory and everything. So that's why this heterogeneous device scheduling is also important for us. The task topology support is another thing that we really like, because for AI training jobs, often we want to run like a pre-run to make sure all the GPU are working before we actually launch the actual AI training job. We don't want to have any like slow GPU or problematic GPU that's in the worker nodes that before we launch the job. So we want to have the test set up, and then after that, the GPU running, we may have some cleanup job as well. So the task topology setup support is really helping here. Finally, the flexible resource sharing and preemption and reclaim, those are like when we share the cluster between different groups or department and teams, that's very helpful feature as well. This is our planned build up for our data center. I don't want to spend too much time over here. This is a physical view, and that's too complicated. So I will show you a simpler view, which is a logical view. So here, when we talk about the logical network topology, with from bottom to up, we have at the bottom we have the tier 1, which is rack. Now we're basically we plan to do GB200, but now because GB300 is released, so we plan to actually install the GB300 NVL72 as our tier 1 rack. So each of the oval here at the bottom, those are a rack of GB300 NVL72, which contains 18 nodes, and each node has 4 GPU and 2 CPU over there. And moving up, if you see the white oval, that's each of them. There are 2 of them in the middle. Each of them represent a tier 2 hypernode. And then on top, which is tier 3 hypernode. So yeah, so that's basically the logical representation of our network architecture. All right, so here. It's not moving. Come on. Okay. The software version are listed here. So if you want to reproduce our product, so because our data center is still building, we don't have a physical. I don't have a physical access to that yet. So now, what I'm demoing today will be a simulated version. So that's why you can see what I use Kind and Quark. Those are just simulate all those nodes in here. Okay, so now let's go to the actual demo. First of all, I want to show you. Okay. First of all, I want to show you that I simulated this this network of how many nodes? We have 118 nodes. And you can see I basically I named them in this pattern so that you can see they're from which region, which zone, and then which DC and row and rack. So at the bottom, you can see we have in this simulation we only have like 1 region, 1 zone, and 1 DC, but we do have 2 rows, and each row have 3 racks, and each rack have 18 nodes. That's basically simulate NVL72 rack. And then let's move to the pods and see what pods are running there. Right. So now there's no pods running. That's perfect. In order to show you like the topology aware scheduling, so I will launch some job on there. I will run some jobs there. Where is my command? Here. First, let me set up my kubeconfig, and over there I will. Okay, here this is the command I'm going to run actually 3 jobs over there. Each of them is simulate LLM training job. So we'll have LLM training 1, 2, and 3. Each of them will require 18 nodes, basically 72 GPUs, and then so basically that requires 1 rack. So what I want to show you is that when you see those jobs get scheduled, each of the job should all reside in 1 rack instead of spreading over multiple racks. So let me try run them all together. Oh, wait. Oh, that's delete. Sorry. My bad. I need to apply. All right. So now our pods are coming up. And you can see now they're running, and they're scheduled and running. And if you look, if you look at all the training 1 jobs, training, I cannot type here. All right. So if you look at all these training 1 jobs, you can see if you look at their, can you see my mouse? Yeah. If you look at their racks, it should be on the same row, same rack. So in this case, it's row 1, rack 02. And that's decided by the Volcano scheduler, not me. Oh, sorry. Why am I typing this? All right. So if you look at, this should be consistent. Or everybody should be on. OK, if you go to the other one, let's say training 2. They should be all sit on the same rack as well, which in this case is row 2, rack 2. This is live, so I don't know what that is, so I have to look at it. All right, and then if you look at the third one, training 3, and in this case, it happened to be scheduled on the row 2 of rack 03, is that right? Yeah, that's right. All right. So they should be consistent. If they're not, then that's a problem, right? So that's how we can make sure that all the pods, they can communicate with really a high bandwidth and using all the bandwidth that's available. So this is our first demo. That's basically for the rack level. Now let me delete all those, and then I will try 2 more. All right, instead let's do apply for the 4 to 5, which each of those are larger jobs, which each of them. Each of them requires 54 nodes instead of the 18. So that requires actually 3 racks. If you remember in our logical view, the 3 racks, there are 2 rows. Each row contains 3 racks. So we actually expect that each job will be contained within 1 row instead of spreading over 2 rows. What is that? See that? What is that? Do you want to enable dedicated? No, I don't. All right. So now this seems to be running, and then I have, let's say, training 4. Okay. And then if you look at them, this one happen to be running on row 1. So you can see 54 of them all running in row 1, right? And then if you say training 5, and then you can see, again, it's 54 of them. They should be on the row 2. So basically, that demonstrates that our topology-aware scheduling is actually working. All right. Let's go back to demo. So now this is done. So I will show you as a summary that first we showed our cluster topology, and then we submitted our job, and then we can see that scheduling work as expected in our real live demo here. How do we enable network topology-aware scheduling? We have to, first, of course, we have to install the correct version of Volcano. Right now, the preview feature is in v1.01. It's preview. And then we have to define all the hypernodes so that, because those are the CRDs that introduced in this version. So we have to, right now, we have to manually create those before network topology, network discovery is available. And then, of course, we have to ask our jobs to use the correct network topology. So when you install a Volcano, make sure to have this correct version over here using basically this tag, v1.01 network topology preview. And this is an example of our CRD. Basically, this is this is a rack level CRD, which you have to say, oh, I have this is tier 1 CRD, and the type, each of its members is a type, is a node, and the node has to match this regular expression of this. That's just how we organize in this demo. Yours don't have to be the same as mine. And then this is a portion of the sample job YAML. The interesting part is that you have this network topologies in the spec. Basically, this Volcano job spec. You can see this YAML file. And then this mode means there are two options for the mode, hard or soft. So in the hard mode, basically, if your job cannot be scheduled with requirement, then it will just be pending instead of going forward. If you have a soft mode, then it would say, and you say, oh, my job want to be confined in tier 1. And if tier 1 does not have enough GPU or other resources, it actually will try to escalate and go to tier 2 to look for more, allow more resources to be used. So in this hard mode, then there's just no such option. Yeah, if you say tier 1, I have to look, all the resources have to be inside the same tier 1. And most of the time, that's what you want, just to make sure that the latency and bandwidth are consistent between all the pods. And then, only this highest tier allowed, this is only usable for when you're using hard mode. If you're using soft mode, then this doesn't really matter. You try from the bottom tier and then go all the way to the top tier. There are still challenges and limitations as of right now, because right now the network topology discovery is not there yet. So we, as a scheduler, Volcano does not include in-band network topology discovery. So we will need to the cloud providers to actually support the network discovery, so that the hypernode hierarchy can be created for the customer without because the customer does not even have the knowledge of the underlying network topology. So it actually relies on cloud provider support. Of course, the accuracy of the topology information, that's when you don't have that support and you manually create those hypernodes. And then the timeline is also crucial. The dynamic cluster environment is that because we know that GPU nodes fail, and when nodes fail, we do remove nodes from the clusters and we add new nodes in. In that case, if that happens too often, then basically you have a challenge of keeping your topology accurate all the time. And of course, finally, this feature is still in early preview. We hope it will mature soon, and then we can use that in production. The future directions, am I out of time? Yeah, OK. Just very briefly, our future plan is that our company will add our own support for this feature from inside our company. And then we'll also hope the Volcano can evolve very fast so that we can mature and then we can use that in production. And then finally, the scheduler performance, tuning, and validation is also needed when we want to schedule a large number of jobs or pods in a short period of time. And here are our contact information. This is how you can find us. And thank you for your support. I appreciate that you stay all the time, all the way to at this time with us. Thank you so much.